Good morning, my dear students. My name is Mukesh Tilwani, Assistant Professor in MLB Textile and Engineering College, Bhilwara, Rajasthan. The subject is Design of Machine Element Second, and the topic is Design of Spring. This is the third lecture of Design of Spring. In previous lecture, I have discussed the stresses developed in the helical spring, and now in today's lecture I am going to discuss the deflection in the helical spring, derivation of the deflection in the helical spring, and the terminology used in compressed. What is the terminologies? For design purpose, we have to know the solid length, compressed length, and free length of the helical spring. First, what is solid length? Solid length, it is defined as the axial length of the spring which is so compressed that the adjacent coil touch each other. In this case, the spring is completely compressed and no further compression is possible. This is a solid length diagram, solid length spring. In this, there is no gap between two adjacent adjacent coils. If there are no gap between the coils, then the spring will form the solid length spring. For what is the solid length in this? This axial length is called the solid length. How to calculate the solid length? It is the nt into t, where nt is total number of the coils and small d is the diameter of the wire. If we can see from the diagram that for one coil, the length of the axial length is small d, then for nt number of the coils, the axial length will be nt into small d. This is a solid length. Now, compressed length. What is compressed length? Compressed length is defined as the axial length of the spring that is subjected to maximum compressive force. In this case, the spring is subjected to maximum deflection. We get the maximum deflection in this case. This is a compressed length spring diagram. In this, the compressed length is the axial length between the coils. In the compressed length spring, there should be some gap. And if we apply the load on the compressive load on the spring, which is the maximum load, if we apply the maximum load on the spring, we get the compressed length and we get the maximum deflection. And what is the maximum force? Actually, this is not the maximum force. It is not more than the load in case of solid length spring. Why we called the maximum compressive load? If we apply the load more than this F maximum, then there should not be gap between there will be not gap between the adjacent coil. If there will not gap between the adjacent coil, then the spring will become the solid length spring. So for the some gap between the coils, this will be the maximum load. After that, we cannot apply the load more than this load, and there should be a gap between this is the practical spring which is used in the applications, different type of application. There should be some gap in the between the adjacent coil. Why there should be some gap? If there is no gap between the coils, the coils will collapse with each other and clash with each other, then the material will damage. For preventing the clashing between the coils, we have to maintain some gap. We have to give some allowance. What is the clashing allowance? The maximum clashing allowance we take in design purpose is 15% of maximum deflection. If the deflection is del, then the gap between the adjacent coil will be the 15% of maximum deflection. Now total gap. What is total gap? In compressed length diagram, we have to calculate the total gap. This is the total length gap. Total gap is the is the gap between the adjacent coil and into total number of gap. First, we have to calculate the total number of gap. Here in from this diagram, if we calculate the total number of coil, 1 2 3 4 5 6, there are 6 total number of coils, and then calculating the gap between the coils are 1 2 3 4 5. If the total number of coils are 6, then the gap between the total number of gap between the coils will be 5. So if there is a gap between if there is a total number of coils are nt, then the gap between total number of gap will be the nt minus 1. For calculating the gap, it is nt minus 1 into gap between adjacent coil. Now free length. What is free length? It is defined as the axial length of the unloaded helical compression spring. In this case, no external force act on the spring. Free length is an important dimension in the spring design and manufacture. What is free length? When in the spring there is no load application are there, then this spring is called free length spring. Before using in any type of application, the spring is unloaded. So we should know the free length of the spring, free length of the spring, so we can use in any type of applications. Therefore, it is an important dimension in the spring design. The free length is compressed length plus del, where del is the maximum deflection. From this diagram, we can see that this is the total axial length is free length. For calculating the free length, we have to know the compressed length and maximum deflection. The free length is compressed length plus deflection, maximum deflection, and the compressed length is the solid length plus total gap between the coils. If we increase the in solid length, if we give the total gap, then we get the axial gap is this much amount. Therefore, the compressed length is equal to solid length plus total gap. Now, pitch of the coil. Pitch of the coil is defined as the axial distance between adjacent coils in uncompressed state of spring. This is an uncompressed state of spring. In this, what is the pitch? Pitch is the axial length between two adjacent coil. We have to calculate the pitch of the coil, so we have to know the free length of the spring. Free length of the spring will then the pitch of the coil will be the free length upon nt minus 1, where nt minus 1 is the total number of gap between the coils. If there are inactive number of coils are there, then the total inactive number of coils will be nt minus 1. Now, deflection of the spring. This is a derivation of the deflection of the spring. I am going to discuss the derivation. This is a diagram of the spring, compressed helical spring. If we apply the load on the spring, the the coil will deflect, the coil will turn, after turn, the complete spring will deflect. So if the first application is, if we apply the load on the spring, the coil will turn, which is the angle of twist. After getting the angle of twist, we get the deflection in the spring. In previous lecture, I have discussed the curvature effect in the spring. In that, if we fix the layer BC and give rotation to the layer AD, then AD will form the another position, which is A dash D dash. Then the angle between AD and A dash D dash will be the angle of twist, which is the turn in for applying the load F. If we apply the load F, we get the angle of twist theta. So for calculating the deflection, we have to know the angle of twist. For calculating the angle of twist, we have to know the torsional equation. For applying the torsional equation, we have to open this spring in the form of bar. In the bar, the torsional equation is T upon Ip is equal to G theta upon L and is equal to tau upon R. The length of the bar is L. We have to know the length of the bar. First we have to calculate the length of the bar or wire. For calculating the length of the wire, we have to calculate the length of the wire for one coil. For one coil is circular coil. For one coil, the total length of the wire is pi into d, where d is diameter of the coil, pi into d is a perimeter of the circle. So for one coil, the wire of the for one So for one coil, the total length of the wire is pi into capital D. Then if there are n number of active coils are there, n number of active coils, then the total number of wire will be the pi D into capital N. This is the angle of twist. How can we calculate this angle? We know the angle is equal to arc upon radius from this diagram. Theta is equal to del upon r, where r is the radius of the coil. Now we calculating the angle of twist. For calculating the angle of twist, we use the torsional equation. We are using the equation this for calculating the theta. T upon Ip is equal to G theta upon L, where G is modulus of rigidity, theta is angle of twist, L length of the wire, T is a torque, and Ip is polar moment of inertia. First, we calculate the torque. Torque is force into perpendicular distance. Here the perpendicular distance is capital R, which is radius of the coil. So the capital T is equal to F into R, where R is capital D by 2, and the length of the wire is pi D into capital N. We put pi d n in this equation, then and the Ip, polar moment of inertia, polar moment of inertia for circular section is pi by 32 into d power 4. We put all these values in this equation. We get the angle of twist 16 f d square n upon g d की power 4. Now, for calculating the deflection, we should know the angle of twist. With the help of angle of twist, we calculate the deflection. Angle of twist is equal to 2 del upon d. 2 del upon d. From this, we get the deflection. Deflection is 8 f d cube n upon g d की power 4. Now calculating the stiffness in the spring. Stiffness in the spring. What is stiffness? Stiffness is load per unit length. It is a property of a material. It is also a property of a spring. So for design purpose, we should know the stiffness. We should know the stiffness. So stiffness is written as small k, denoted as small. Thank you so much, students, for watching this video. If you have any doubts and query, you can comment. I will reply your comment. Thank you so much.